This meeting is being recorded.
Problem 26 from chapter 2 gives us these three structures and asks us to draw all these significant resonance forms and then rank them from most significant to least significant and give a brief explanation. So that's what I have written down here. So we see in structure A here, we have a benzene ring with this NH. So we see a negative formal charge on the nitrogen in structure A and two lone pairs drawn in red. So one of those lone pairs will be in this first curved arrow. So that will form a double bond, and then the carbon that new double bond forms right here with, that's already involved in a double bond. So those electrons will then be moved onto the carbon atom over here. So that's what we see in this first structure down here. And then there are two more movements of electrons, two more resonance structures in addition to this first resonance structure drawn. So we have a total of 4 resonance structures for this first compound, and we'll see the movement from a lone pair over here to form a double bond, and then a double bond to form a lone pair. And then we'll see that same pattern again, lone pair to form a double bond to form a lone pair. And then our final structure, we see that nitrogen is no longer negative, but that negative charge has moved to a carbon atom. And all 3 of these structures are equivalent. The first resonance structure, that would be our main contributor, our number 1 contributor, since nitrogen has the negative formal charge and it is more electronegative than carbon. For structure B, I drew the 2 resonance structures, so only 2 total down here for B. The 2 structures are drawn down here. They are equivalent, so they're both the main or most significant. So we see a lone pair on the carbon to the right here that moves and forms a double bond, and then that carbonyl that's already there, that double bond, those electrons move to form a third lone pair on the oxygen, so that -1 formal charge moves to a different oxygen. But again, they are equivalent structures. Then we have compound C here. So we have a symmetric compound with 2 lone pairs on the oxygen. So the oxygen, one of those lone pairs will move to form a double bond, and then the double bond that's already there, so this carbon, right, it forms a new double bond, so at the same time double bond it's already involved in, those electrons will move down here in this compound to the end. So then we see this out of 3 total resonance structures. We saw the first that we were given, and then we've just created this second structure. So we're going to move that lone pair on the end of the right side of this second resonance structure, and that will form a new double bond. The double bond that's already attached to this carbon will then move over here on the other side of this oxygen. The oxygen will remain with a +1 formal charge throughout this, but that -1 charge will then move to the other side because that pi bond that's already there, those electrons will move to the end here in this final structure. So these are the 3 resonance structures for molecule C.